Hey everyone, here's our 1.6 latent heat five-stepper question for those of you who want to see how to do a five-stepper or just need another example. So how much heat is lost when you have 100 grams of steam at 105.1 degrees Celsius turning to ice at negative 6.8 degrees Celsius? So our first step is to see if we have any state changes. And we obviously are, given the context of the question, because I'm starting with steam and I'm turning to ice. So I will have to make my staircase. I'm going to make it bigger just a sec. There, that's a bit better. Okay, so our givens. So drawing our staircase, now doing our givens. So we have 100 grams of steam. So our mass is 100 grams. But remember, I need it in kilograms, so this is 0.1 kilograms of steam at 105.1 degrees Celsius. So here I have solid, liquid, gas. Steam is water in its gaseous phase, so this is where I'm starting, just anywhere here. Put your line. And 105.1 degrees Celsius. And I am going to ice. So ice is solid. So down here in this section, so just draw a line. So solid ice at negative 6.8. Negative 6.8 degrees Celsius. Okay, if I was going to solid ice at 0 degrees Celsius, I would stop here, and this would be a 1, 2, 3, 4 stepper problem, but I am going to ice that is below 0 degrees Celsius, so this will be a 1, 2, 3, 4, 5 step problem. So here I'm going to be going, got to go down here. So to turn my steam down to 100 degrees Celsius, where it will start to turn into water. So it will condense into water. And then down here, I'm turning my water at 100 degrees Celsius to water at 0 degrees Celsius. And then turning my water at 0 degrees Celsius, freezing it into ice at 0 degrees Celsius. And then all the way down here, turning my 0 degrees Celsius ice to negative 6.8 degrees Celsius ice. So this will be 1, 2, 3, 4, 5 steps we need to do. Okay, so grabbing our other givens, so the things that we're going to need. So when we are going through anything with a temperature change, remember I'm going to be using Q equals mc delta T. So for this section, for Q equals mc delta T, for my first step, I need a mass, which I have, I need a C value, which I will look up, and I need a delta T, which I can calculate right now. So my change in temperature here will be, I'm going from, this is my T2, here's my T1. So I'm starting at 105.1 degrees Celsius. I'm ending up at 100 degrees Celsius. So my change in temperature is I'm going down in temperature 100 minus 105.1, and I get negative 5.1 degrees Celsius. Okay, so my change in temperature for my first leg of my journey is negative 5.1 degrees Celsius, and my C value for steam. Okay, so I need to make sure I'm looking up the C for steam because this is where I have steam. So here we go. Specific heats of common substances. Here we have steam. It's 2020. So 2020. That's everything I need for my first step. Okay, let's take a look at our second step. So step number 2, I'm not changing in temperature. So step number 2, I'm going to be using Q equals M and then H, now F or V. Well, this is going to be my heat of vaporization because I'm going from some sort of vapor, so steam, to something else, or I could check here from our notes and be like, oh, right, okay, so I'm here and I need my HV. So MHV. So I have my mass. We just need to look up our HV value. So here, water or ice or steam. So here's our HF value. Here's our HV value. So 2.26 times 10 to the 6. So 2.26 times 10 to the 6 joules per kilogram. Okay, so that's for there. Next step. Let's do green. Okay, so step number 3, we're back to Q equals MHF, or MC delta T. Okay, because I have a change in temperature going up and down. So I have my mass, I can figure out my change in temperature. So my change in temperature, I'm starting at 100 and I'm going to 0. So T2, I'm going to 0 minus 100. My change in temperature is negative 100 degrees Celsius. Okay, and my C value for water, you might have memorized already. So C for water is 4,180 joules per kilogram degrees Celsius. So that's that, and that. We're good to find everything there. So next step, step number 4, can't use Q equals MC delta T. This will have to be our Q equals M, 4, Q equals MH F, our heat of fusion, which we could check from our staircase in our notes. And so I need to figure out my heat of fusion, or sorry, look up my heat of fusion for water / ice. So grabbing our, there we go. Grabbing our heat of fusion, 3.34 times 10 to the 5. And joules per kilogram. That is supposed to be A5. There we go. All right, so that's all settled, M and HF, and our last step. So givens take a while, but done properly, it's going to make your life a lot easier. Okay, so my chain here for step number 5, I'm going to need Q equals MC delta T again. This color 5. So Q equals MC delta T. And so my change in temperature is I'm starting at 0, so ice at 0 degrees Celsius, and I'm going to ice at negative 6.8 degrees Celsius. Okay, so this is where I'm ending up at, so negative 6.8 minus 0 is nice and easy. It's just going to be negative 6.8 degrees Celsius. Okay, so now we have all of our information. Oh, no, not yet. Sorry, I lied. We got our delta T, we need our C. So sneaking over, our C value for ice is 2060. So 2060 joules per kilogram degree Celsius. Now putting it all together. So doing each of our steps, finding out how much heat is being lost. Because remember how much heat is lost. Adding it all together and stating our final answer to the correct amount of sig figs. Okay, so Q equals MC delta T for step number 1. So for step number 1, mass is 0.1 kilograms. C is the C of steam, so 2020 joules per kilogram degrees Celsius. And our change in temperature is we're going down, negative 5.1 degrees Celsius. Okay, calculating that, and we get negative 1030.2 joules. Now remember what this negative means is that we're losing heat. So I can tell that I'm losing heat by calculating my change in temperature and seeing that I'm losing heat, but it also says in the question, you're losing heat. So if we are losing heat, we should be getting a negative answer. Now, if you just did this with 5.1 degrees Celsius, you're saying you're gaining heat. As long as you recognize when you get to the end of your question that all of this heat should be lost, you're fine. Okay, so if you calculate these without the negative, you can still arrive at the right answer by thinking through logically what is happening in this question if you don't like dealing with negatives and stuff. Okay, so next step. So Q equals mHV. So Q equals my mass, which is 0.1 kilograms, multiplied by the heat of vaporization, which is 2.26 times 10 to the 6 joules per kilogram. Okay, calculating, and we just get 0 joules. Okay, so I did not leave it in scientific notation. So we get 226,000 joules. Now, here's the problem. Since there is no temperature change, you can't really tell from your Q equals mHV or your Q equals mHF equation if you are going to be gaining or losing heat. So this would be a situation where we have to recognize that we are losing heat, so we put the negative in ourselves. Or once again, if you don't like dealing with the negatives, don't put the negatives in and then deal with them at the end by looking back at your question. Okay, so next step, our green step. So Q equals mc delta T. So mass hasn't changed, still 0.1 kilograms. Now we're doing the C of water. Okay, so 4,180 joules per kilogram degrees Celsius. And our change in temperature is we've gone down 100 degrees Celsius. So calculate that, and we get negative 41,800 joules. Next step. So Q equals mHF. So M starts 0.1 kilograms. HF is 3.34 times 10 to the 5 joules per kilogram. And calculating. To move that down, you get negative, because remember we are like, you don't get a negative in your question, but we are losing heat still. So I can put my negative in myself, negative 33,400 joules. And last step. So Q equals mc delta T for step number 5. So from ice at 0 degrees Celsius to ice at negative 6.8 degrees Celsius, my mass is 0.1 kilograms. My C value for ice is 2060 joules per kilogram degrees Celsius. Oh, sorry guys. After I have too much ink on here, it really slows down. Darn you, 5-step question. Okay, oh, it's painful. And our change in temperature is negative 6.8 degrees Celsius. Oh, okay. And calculate. Holy mackerel. So, and sorry. And we get negative, come on, buddy. Okay. 1,400.8 joules. Okay, now our last step is to add up all our steps. So this is how much heat we lost in our first step, our second step, our third step, our fourth step, and our fifth step, adding all of those together. Okay, just did it by myself. So adding our 5 values together, and we get negative 30,363 joules. Or sorry, negative 303,631 joules. Did I say that? I don't know. Okay, so this is what we get when we add all of ours up together. Now, taking a look at our significant figures, 3, because that decimal, sneaky little decimal there, so 1, 2, 3, 4, and 2, so we will round to 2 significant figures. But when we cut it off at 2, we recognize that, oh, that's only one significant figure, so we have to put it into scientific notation. So we get negative 3.0 times 10 to the 5 joules. Now there are two ways that we can have the correct answer for this. So we asked how much heat was lost. The negative shows us that heat was lost. So this indicates that you know what was happening in your question by having that negative there. The other way is to, if you don't like dealing with those negatives, you can calculate it all with positives and get a positive answer and then recognize that heat is lost. So you would write your answer as 3.0 times 10 to the 5 joules lost. So that lost and that negative tell me the same thing, that you recognize that heat was lost in this question, not gained. Okay, so either have the negative show that heat was lost or put lost at the end of a positive number to explain that. Okay, bye.